So now let us take a step back and see how we would apply this information in order to do policy enforcement, which is a combination of quality of service, access control, and firewalls for the traffic coming from different users. So typically, the way traffic goes through the Meru system is that it first goes over a wireless edge from a device to an access point, and then it goes over a back-end tunnel from an access point to a controller, and then logically it goes northbound from the controller to the wired system. And while it hits the controller, this is where the policy enforcement engine hits it. Now, what is visible in terms of user traffic at this point? We have the source IP, we have the destination IP, we have the source port, destination port, we have the protocol, and we have the filter ID. If you remember from the previous discussion, once a user logs in, they get a filter ID. Depending upon which user is transmitting, this filter ID is also gleaned in the controller from the traffic that they send. So this 6 tuple, the source and destination IP, source and destination port, protocol, and filter ID are used for classification. So notice that this now adds 2 additional dimensions, IP-based and application-based. To summarize then, the way packets are classified is based on user, service, location, IP, and application. This is the first step of the policy enforcement, which is classification. And of course, you can define classification rules based on any combination of these 6 parameters. Once the traffic gets classified, we identified a particular session ID. And now it goes through the second phase, which is the flow mapping phase. In the flow mapping phase, a particular session might retain itself as an individual flow, or multiple sessions can get aggregated into a single flow. So step 1, classification. Step 2, flow mapping, where you can treat each session, in other words, each of these sessions, 5 tuples or 6 tuples, each TCP connection, individually, or you can map and aggregate them all to one. One instance of aggregation would be if the policy of the customer here is that all guest users in aggregate will get a maximum of 1 megabit per second. In that case, what you do is you classify the packets, and of course you assign a filter ID based on the SSID that the users connect to, and all the sessions that match this particular filter ID will get aggregated into a single flow. Once that happens, we then go into the action side. In the action, there are essentially 3 operations one can do. You can either forward the packet, or you can drop it, or there is a third element in our system which is called capture, and I'm going to get to that in a second. So when you forward packets, you might forward the packet preserving its original QoS tags, in other words, quality of service tags, or it is possible for the system to actually overlay these quality of service tags by writing some additional or overwriting it with configured tags based on the policy rules. In addition to QoS tagging, we also support rate limiting. And this is token bucket based rate limiting, which is a concept that should be familiar to pretty much anybody in the field who understands networking. And the idea here is you classify, and then you aggregate, and then you can rate limit on a per session or an aggregate basis. So when I was giving you the example of all the guest users being rate limited, first sessions come in, they get aggregated into a single flow, and then we apply the rate limit on that particular flow. So at this point, I hope it's clear how the forwarding, dropping, and the changing of the parameters during the forwarding phase works. So the remaining aspect is how to deal with capture. And this is interesting because in the Meru system, we actually have application-aware packet classification and treatment. So let's take an example. If you're running a SIP voice call, in the application itself, the signaling protocol SIP is completely decoupled from the actual packet transmission, which happens over the RTP stream. So what we do is write rules to capture SIP packets. Capture meaning that there is a local process in the controller So you could forward, drop, or capture. So we'll capture the SIP packet. We will parse it by doing stateful deep packet inspection. We'll figure out the source and destination phone numbers. We will figure out the P time, which is the periodicity of packet transmission. We will figure out the data rates, and essentially we'll figure out the total resources that are required. And on that basis, we can do call admission control. We can do more enhanced voice management capabilities, which will be dealt with in a companion video. So the point here is that the quality of service and firewall policy framework allows us to capture packets and then instantiate application modules or application-aware modules that then provide treatment on the packets. And at that point, they may throw the packet or they may forward it. In the SIP case, for example, the SIP flow detector module parses it, figures out whether you can support call admission for that particular call or not, and if so, simply forwards the packet transparently. So devices northbound never know that these packets have actually been opened and peered into, and action has been taken on them. So at this point, let me step back and summarize all the capabilities of the system. There's classification, flow mapping, and action. The action combines firewall, such as dropping, along with quality of service, which is tagging and rate limiting, along with application-aware treatment of flows, which is through packet capture. Thank you.